Hello everyone. In this video, we are going to discuss some problems on energy signals. And here we are having a problem. Determine the total energy of the signal shown below. We are going to find the total energy of the signal which is mentioned here. The signal is x of t. You can see the signal is x of t, which is having an amplitude a. X of t with an amplitude a, which varies from minus t by 2 to plus t by 2. Okay. Now let us solve this problem. From the figure, the value of x of t is equal to a. The value of x of t is equal to a for t between minus t by 2, t is greater than minus t by 2 and less than plus t by 2, right? And the value of x of t is 0 otherwise. The value of x of t is a, the amplitude of x of t is a between minus t by 2 and plus t by 2, and for remaining values the x of t is 0. We can see this. Okay. Now, since the value of x of t is a, the amplitude is a, remember a is an integer. Remember that a is an integer. And we know the total energy of a continuous time signal. Total energy of a continuous time signal is given as capital E is equal to integration of minus t by 2 to minus infinity to plus infinity x of t whole square into dt. Total energy is integration of minus infinity to plus infinity x of t whole square into dt. Since the limit for this problem is between minus t by 2 to plus t by 2, we can mark the energy E is equal to integration of minus t by 2 to plus t by 2. The value of x of t is between minus t by 2 to plus t by 2. The value of x of t is a square. Now x of t is a, since it is a square, we are multiplying it again into dt. Now we got the energy signal as E is equal to capital E is equal to integration of minus t by 2 to plus t by 2 a square into dt. Okay. For that, E is equal to integration of minus t by 2 to plus t by 2 a square into dt. As we said, a is an integer. Since a is an integer, integration of a constant term a leads to a square into t. Since we are integrating it with respect to dt, a square into t limits minus t by 2 to plus t by 2. Limits minus t by 2 to plus t by 2. Therefore, keeping a square aside, for t we are applying upper limit and the lower limit. While applying upper limit, first we are going to apply the upper limit. For t, it is upper limit is t by 2 minus the lower limit t. The lower limit is minus t by 2, minus of minus t by 2. Upper limit minus the lower limit. Lower limit is minus t by 2. Now we got a square into t by 2, minus into minus is plus t by 2. T by 2 plus t by 2 leads to t. Therefore, the total energy of the given signal is a square into t. Okay. This is the total energy of the signal. Now, moving on to our next problem. Here we are having a problem like determine the total energy of the signal x of t is equal to phi cos pi t. X of t is equal to phi cos pi t. Now we are going to apply energy formula. Under the solution, we know since it is x of t, which means we are dealing with a continuous time signal here. Okay, since it is x of t, we are dealing with a continuous time signal. We know total energy of a continuous time signal is given by capital E is equal to integration of minus infinity to plus infinity x of t whole square into dt. Right? Now, substituting the value of x of t before substituting the value of x of t, we need to know the limits. Since we are having half of the problem, x of t is equal to phi cos pi t for limit minus 1 to plus 1. Okay, x of t is equal to phi cos pi t between the limits minus 1 to plus 1, otherwise the value of x of t is 0. Now we got the problem, and applying the limits minus 1 to plus 1, integration of minus 1 to plus 1, x of t value is phi cos pi t, need to square it into dt. Now we substitute the value of x of t as phi cos pi t. Now integration of minus 1 to plus 1, phi square is 25, cos pi t whole square is cos square pi t into dt. Okay, since 25 is a constant, we can keep it outside the integration. 25 into integration of minus 1 to plus 1 cos square pi t into dt. Okay, as we all know, cos square theta is equal to 1 minus cos 2 theta divided by 2. Okay, if you people doesn't know, please do mark it out. Cos square theta is equal to 1 minus cos 2 theta by 2. Since we got cos square pi t, we can substitute this formula here, and we will get 25 integration of minus 1 to plus 1, 1 minus cos 2, here in place of theta we are having pi t, divided by 2 into dt. Okay, now we got the equation as E is equal to 25 integration of minus 1 to plus 1, 1 minus cos 2 pi t by 2 into dt, which we can mark it as 25 integration of minus 1 to plus 1, 1 by 2, can split these two terms, 1 by 2 minus cos 2 pi t by 2 into dt. Okay, which we can mark it as 25 integration of minus 1 to plus 1, 1 by 2 into dt minus whole bracket, we can take it as whole bracket, first term a minus b formula, integration of a minus b, we can mark it as integration of a minus integration of b, minus 1 to plus 1 cos 2 pi t by 2 into dt. Okay, 25. Integration of a constant is again constant with the a term 1 by 2 into t with limits minus 1 to plus 1. Integration of 1 by 2 into dt. Since 1 by 2 is a constant, 1 by 2 into integration of nothing is 1. Integration of 1 is t with the limits minus 1 to plus 1 minus. Since cos 2 pi t by 2, we can take 1 by 2 outside. 1 by 2 integration of minus 1 to plus 1 cos 2 pi t into dt. 25. 1 by 2 into t, upper limit minus the lower limit. 1 by 2 into upper limit 1 minus of minus 1, right? Upper limit minus the lower limit is minus 1 minus 1 by 2. Integration of cos theta is sin theta. Okay, we'll get 2 pi sin 2 pi t with limit minus 1 to plus 1. Okay, for that 25. 1 by 2, 1 plus 1 is 1 minus of minus 1 is plus 1, 1 plus 1 is 2 minus, remember sin 2 pi is 0. If you apply the upper limit or lower limit, t will be plus 1 or minus 1. Sin minus 2 pi or sin plus 2 pi tends to 0. This whole term tends to 0. Hence, the second term will mark it as 0. We'll be left with 25 into 1 by 2 into 2 get cancelled. We'll be left with 25 into 1 as 25. The total energy of a signal cos 2 phi cos pi by 2 pi t. X of t is equal to phi cos pi t is 25. Okay, this is the total energy of the signal. X of t is equal to phi cos pi t. Now let us consider a few more problems with respect to the energy signal. Determine the energy signal of the sequence x of n is equal to 1 by 2 power n between n greater than or equal to 0 and x of n is equal to 0 for n less than 0. Okay, this is the problem. We got x of n is equal to 1 by 2 power n for n greater than or equal to 0 and n is x of n is equal to 0 for n less than 0. Let us solve this problem. We know total energy of a discrete time signal. We know the total energy of a discrete time signal is equal to summation of n is equal to minus infinity to plus infinity x of n whole square. This is the total energy for a discrete time signal. Now we got the value of x of n as 1 by 2 power n between for n greater than or equal to 0. Now substituting a is equal to summation of n is equal to, now the limit is greater than or equal to 0, n is equal to 0 to infinity. The value of x of n is 1 by 2 power n whole square. Therefore capital E is equal to n is equal to 0 to infinity 1 by 2 power 2n. Okay, Now we got this one as E is equal to summation of n is equal to 0 to infinity 1 by 2 power 2n. Let m is equal to 2n. Let us substitute m is equal to 2n or n is equal to m by 2. We'll get E is equal to summation of m is equal to 0 to infinity 1 by 2 power m. In the place of 2n we are substituting m, and in place of n we are substituting m by 2. Here we got n, which means m by 2. M is equal to 0 or m by 2 is equal to 0, one and the same, because you can see, yeah, if m by 2 is equal to 0, m is equal to 2 into 0 is 0, and for the upper limit, if m by 2 is equal to infinity, m is equal to 2 into infinity is again infinity. We can write it as E is equal to summation of m is equal to 0 to infinity 1 by 2 power m. Okay, now we got this problem like in a standard formula. The standard formula says summation of n is equal to 0 to infinity alpha power n will be equal to 1 divided by 1 minus alpha for alpha less than 1. If the value of alpha is less than 1, then summation of n is equal to 0 to infinity alpha power n will be 1 divided by 1 minus alpha. And here we got 1 by 2, which in the place of alpha we are having 1 by 2, and 1 by 2 is nothing but 0.5, which is less than 1. Therefore we can substitute this formula. In the place of n we are having m. Okay, therefore energy is equal to alpha 1 divided by 1 minus alpha 1 divided by 1 minus, the place of alpha we are having 1 by 2, right? 1 divided by 1 minus 1 by 2 is 1 by 2, which can be rewritten as 2. 1 divided by 1 by 2, 2 will go to the numerator and we'll be having total energy E is equal to 2. Okay, therefore the total energy of the signal x of n is equal to 1 by 2 power n is 2. If you have any doubts, so please do message on my comment box. We'll be connected. Thank you.